Hello guys, so today I wanna have a couple of the questions from the week 8 material, and actually I think you will see these questions in week 9 in the upcoming weeks. So still the questions are not published, so I don't know about the questions exactly, but I reckon that you will see some of the similar questions. Now, here is this question. Let's have a look at this one. So, part A. So I'm gonna use this table, and firstly, I will have to constitute the. So it is characteristic equation. It is this one. So it's second order. This doesn't have any constant, so it is homogeneous, and it doesn't, none of the an minus 1, they're all power 1, so it is linear. So we will use this linear coefficient recurrence relation. So we will use this like here, you see that I will use this one and I will solve this one. So this means let's use x squared equal 5x, which is 5x plus b. B is the coefficient of this guy, minus 6. From here, I can write this one as this one, so I can decompose this one, finding two numbers which their multiplication is positive 6 and their addition is minus 5. All right, so let's look at this one. So we see this one, so my answer will be this guy. So S or AN here will be A. So R1 is 2, R3 is 3. So it will be 2 power n. So if you see that R1 is 2, so it is x equal R1, or the root of this one, x equal 2. And R2 here, not R3. Okay, so this will be this guy here. So we're gonna write this one, plus b times 3 power n. Now, this is the initial condition has given to us. So can I use A0, which is here, equal to A 2 power 0 plus B times 3 power 0. So this is equal to A plus B. Any number power 0 is 1. And 5 equal A1 equal A times 2 power 1 plus 3 power 1, 2A plus 3B. So from here, can I add one page? So you can solve this one. So definitely, so A plus B equal 2, I can rewrite this one. 2A plus 3B equal 5. And this guy can be written as minus 2A minus 2B minus 4. I multiplied it just by minus 2. 2A plus 3B plus 5. From here, B is 1. And I can use this guy, and I can see that A will be 1 as well. So AN is A times, so have a look at here. So A is 1, so 2 power n plus 3 power n. So we can obtain the recurrence relation explicitly. Let's have a look at the part B. Okay, part B is this guy here. Tn equal to Tn minus 2. From here, I can see that x squared equal to 1 from here. So x squared equal ax plus b. So a is 0 because there is no coefficient for t sub n minus 1. b is equal 1. From here, x is equal plus minus 1. So you can continue like previous. So this will be Tn 1 power n b times minus 1 power n. All right, so this is a plus b minus 1 power n. You can understand a and b by using the initial condition here, t0 and t1. So let's have a look at this one. xn plus 4 minus 4. So c xn is plus 4 xn minus 1 minus 4 times. Okay, from here, x squared equal 4 x minus 4. Okay, as a result, 4x plus 4 equals 0. Therefore, x minus 2 squared equal to 0. X equal plus 2. From here, so can I use this table here? So you see that this guy, it's like this one. So a, so you see that, so a and bn, so it will be just r, so which is this one, and I will just multiply for the second solution. I will multiply rn by just one more n. All right, so this guy will be, what was it? S xn. All right, so xn will be equal to a times 2 power n plus b n 2 power n. So then definitely you've got x0 and x1, and you can understand the a and b from here. Now, this was the finding the homogeneous linear second order recurrence. Let's have a look at the first order linear recurrence, but the non-homogeneous version. This one is the special one. So the explicit formula is given to us. All right. So the famous problem is about this version. So an is given to us here. So we need to, the key is this, to understand what the b is and what the c is. So c is the easy part. C is equal minus 1 because it decreases our investment, our money, and this guy is like 1% is going to add 1%. So so let's have a look at write a couple of them. A1 will be A0, which is A0 is $1,000. It's written here as well. And A0 times 1% plus A0 itself minus 1. So this will be A0 times 1.01 minus 1. So A2 will be A1 itself. 1% of the 100ths of A1 will be added to the original, to the previous one, minus 1 as well again. All right. So this will be for A1. So now we can understand AN now here. So here's the thing. Let's add the page. Okay. So AN. So let's see that B is 1.01 here. Okay, an is equal to what's the formula? So I'm just gonna follow this guy, this relationship. An, so 1.01 power n. A was what? A was what? This one here, 1000, plus C is -1, and this guy is B 1.01 power n minus 1 divided by B minus 1, which will be 0.01. All right. So this is the this for solving this one. So you can, and also we can understand a sub 12 as well. So we can do this 12 minus. So if I have, so -1 here, so I will have another -1 again. So this will be -10. So sorry. So this is -10 is for this one. So -1. So there is no -1 here. -1 here. And I just confused. Okay. And you will apply the formula 12 -1 and the rest of the story. All right. So you can do the same job for the part B as well, provided that C is -10 there, and the rest is the same job. All right, so we move to the other question now. Second order linear, but non-homogeneous because of this guy. So this guy can be written as, just quickly. So what do we want to write? Sn, general solution plus particular solution. All right. So general one is means this part. And you can understand, we can understand that x squared, x plus 2. From here, x squared minus x minus 2 equals 0. So I should add one page now. So this will be x will be minus plus 1, x minus 2, because 1 and minus 2 is minus 2, and 1 and plus minus 2 is minus 1, which satisfy here and here. So therefore the general solution for this part is a times -1. So here we've got R1 is -1 and R2 is R1 or X or R1, R2 or X1, X2 will be 2n plus b times 2n. Now, the particular solution, now we are after for this part, okay? So let's have a look at the table. So when the constant is the non-homogeneous part is the constant. So what we want to do, we will choose Sn as to be D. So we will try to figure out what the D is. So original solution, okay, Sn equal Sn minus 1 plus 2, Sn minus 2 plus 1. So let Sn is D. So it's a constant. So this is D. So this will be D. Therefore, D equal D plus 2 times D as well plus 1. These can cancel each other. From here, D is minus half. As a result, Sn will be the thing that we obtained already, this guy. So which is like this one. Plus B times 2 power n. And plus D, which is minus half. All right. That is the final solution for this non-homogeneous second order. Let's have a look at this guy here, non-homogeneous part. It is the same thing, but you can use this boundary condition, like initial condition, to understand this. So by using these two conditions, S1 and S2, you can A and B. So I keep saying initial value or boundary condition. It's because this topic is like, it looks like the solving constant coefficients in ordinary differential equation. So I don't do that, but instead I can do this one. So again, Sn, general solution plus particular solution. The general solution is the same as the previous question. So it will be Sn A times, what was it? Here. This guy, A times minus 1 plus B times 2 power n. Now, the here is 2 power n minus 1. So let's have a look at the table here. So we see that here, like when the non-homogeneous part is a polynomial of k, of order k, which is of order 1, because it's 2n minus 1. So it's like order 1. The highest degree is just 1. And I will choose C1 plus C2n. So k equal 1. So k equal 1. So I will choose this guy as particular solution, and we'll try to understand C1 and C2. All right, so let's go there. So particular solution. Sn equal to C1 plus C2n. So I will sub in recurrence equation. So I will sub it here. So it will be C1 plus C2n equal to C1 plus C2 times n minus 1, because S sub n minus 1, plus C1. Oh, sorry. Should do this, plus 2 times C1 plus C2 times n minus 2 plus 2n minus 1. From here, C1, can I simplify it? C1 plus C2n equal to C1 minus C2 plus I try to gather just the constants T2C1 minus from here minus 2C, and then there is another 2, so it will be minus 4 C2 minus 1 plus n times, so C2 so because I have C2 here, then plus 2 C2 here as well, 2 C2, and there is another 2 here, so plus 2 here. So now can I simplify much more? C1 plus C2n equal to, so this guy will be this one, 3C1 minus 5C2 minus 1 plus n times 3C2 plus 2. So 3C2 plus 2 C2. So this guy must be equal to this guy. So from here, C2 will be just minus 1. And from here now, 3C1 minus 5C2, which is minus 1, must be equal C1, which is this constant. So the constant of the left-hand side equation will be this one, which is equal to the constant of the right-hand side of the equation. Coefficient of the n C2 on the left-hand side must be equal to the coefficient of the n in the right-hand side, which is this one. So that's how we find C1 and C2. So C1 from here, this comes this side, it will be 2 C1, and this is positive 6 with minus 1 goes to other side, will be minus 5. So from here, C1 is minus 5 over 2. Therefore, so it is possible for me to have a mistake, so you can correct me, but all in all, Sn will be a times minus 1 power n plus b times 2 power n, then plus C2 plus C1 times plus C2 times n. So can I, so let me rewrite this minus n. So now everything is right, I think. So it is, sorry, so can I amend this one? So this will be positive 5. And it goes to the other side, it will be minus 4. And this will be just minus 2. So can I amend this? Minus 2. Minus 2, and this is minus 8. Now everything is right.